Who has ever played with cryptography stuff before? Some little bits?
Well, CTFs.
A little bits or CTFs.
Certificates, SSL certificates.
SSL. How many have you done with like code breaking type stuff?
Caesar ciphers.
A little bit.
Okay.
Caesar
Okay. So this entire talk will be focused on what's kind of commonly referred to as classical crypto. So this is all before computers. So classical crypto, all before computers, a lot easier to understand because it was done by someone in like the 9th century BC writing on pen and paper. But all of the things apply to modern cryptography as well. So we'll just sort of touch on that. So first, knock out like 3 vocab words just that are kind of important. So everyone knows what I'm talking about. The plain text is your message. The ciphertext is your scrambled message. And then the key space is the number of possible key combinations. The key combinations might become more understandable later on. So kind of a little bit of history, as I mentioned before. Cryptography is very old. The top is a scatel, which was an ancient Greek method of cryptography, which you'd wrap a piece of it wasn't paper, it was cloth, around a post, and then you'd write across it, and then you'd unravel it, and you'd send a ribbon of letters, and the person on the receiving end would have a post of the same thickness, so they'd be able to rewrap it, and based on the thickness, they'd be able to read it easily. If you didn't have that post, it'd be a different size, and so the letters would wrap differently, so you couldn't read it. So kind of a basic, old-fashioned way of doing it. You have the Caesar cipher, which we'll go into a lot more later. One of the things about cryptography, it doesn't have to be perfect. If I'm trying to encrypt a message, we're going to attack at dawn. I only need the enemy to not know what that message said until tomorrow afternoon, because if they don't realize we're attacking at dawn, after dawn, I've probably already won at that point. So that's one of those things that's worth looking at when you're looking at cryptography is if your type of crypto keeps your message safe as long as it needs to be safe. You'll hear some stuff about quantum computers and whatnot breaking all of modern crypto. That's not a huge threat to it for us personally right now, because if someone captures your bank information and then decrypts it in 10 or 15 years, that's probably not going to be super useful for them in 10 or 15 years. It is a problem for the NSA because their information might still be important in 10 or 15 years. If you start developing a mole or something, you don't want that mole, once they become the supreme general, to be outed. So just one of those thoughts. We'll go through a couple of the classical ciphers kind of building on each other. The first one, as I mentioned before, was kind of the Caesar cipher. Who all has heard of the Caesar cipher? Okay, everyone has heard of the Caesar cipher, so I won't go into a huge amount of time explaining that. One of my big things is the key space, as I mentioned before, is literally 26. How many different types of rotation you can do, which makes it really easy to crack even before modern computers, because you can do 26 things on paper, within 30 or 40 minutes. Then there are monoalphabetic ciphers. This is basically take an A and change it into something else. Change it into an R. Change a B into a Q. Everything has a one-to-one mapping. You'll see this sometimes with symbols. Maybe I've seen it with emojis for some stuff. An A is a laughing face and a B is a sad face. So then for CTF challenges, you'll just get a huge thing of emojis, and you'll have to break that. And that's normally a monoalphabetic cipher. And then a Visionaire cipher is a monoalphabetic. Caesar cipher is also monoalphabetic, but it has a fixed kind of key space, or a much smaller key space. The Visionaire cipher takes kind of the idea of a Caesar cipher, you shift it a certain numbers, but then will give you a word. So for example, hello, with the password of IASG, I'm just going to assume I is the 10th letter of the alphabet, so then you'd shift H 10 spaces. You'd shift E 1 space, and so on. So this way you have a bunch of different keys. So probably should have had an alphabet on top with numbers, which is kind of one of those basic cryptography baking things. So breaking codes.
What's the difference between Caesar and rock ciphers?
They're the exact same.
Okay. So
When people say Caesar cipher, they sometimes mean with the key of 3, because that's supposedly what Julius Caesar did when he was planning his takeover of Rome or whatnot. It's the way it was taught to me, was that they used the vocabulary of Caesar ciphers. Rot ciphers are also. They're the same. Rot 13 is rotating, so it includes the key in it basically. Assuming that you have English, and it's a very large amount of text, how would people break the Caesar cipher? Yeah.
Frequency analysis.
Seems like a lot of work for a Caesar cipher.
See which one makes sense.
Yeah, do it. You said do it 26 different times?
Yeah, let's do it.
Yeah.
Makes sense.
Yeah, just
Brute force.
brute force.
Yeah, I'm lazy about it, sure.
Yeah. So that's something that's also always worth considering, especially now that we have computers. If you see a code, there's a lot of fun things on the internet that just does stuff for you. It's fun to do stuff by hand, and I'd recommend doing it once or twice. But if you're in a challenge, if you have you have to move quickly, just brute force it if you have the computing power to do that. A monoalphabetic cipher, like a 1-to-1, emojis to letters. Any thoughts on that? No.
Well, then you could do frequency analysis, or you could kind of do a hangman or Wheel of Fortune style of guessing,
Mm-hmm.
just to see what makes sense.
Yeah, that's literally my entire next slide. So basically, if you guys don't know, English letters are not distributed evenly. There's a lot of E's and there's not a lot of Z's and J's in the English language. So if you have a large enough thing of text, dump it in a nice program that counts how many J's there are, how many E's, etc. Or different types of emojis. And the largest one is probably E. The next one, T, A, O, I, etc. Depending on how large the text is, it's not always the case. Some stuff flips around. You can see, like in here, R and H are really close together. So just by randomness of what text you get, that might be flipped. Or I think it was like the Great Gatsby possibly didn't have any E's in it or something, because Fitzgerald wanted to see if he could write a book that didn't have any E's in it.
Oh, Green Eggs and Ham never used something. I think it might have been like the word E.
Yeah,
Yeah,
but the kind of the point is not all English, not all messages are exactly normal English, but this gives you a really good place to start. Also, as you pointed out, if they're nice enough to leave the spacing in there, there's only so many 2-letter words in the English alphabet. If you see a 2-letter word, it's probably it or is. A 3-letter word is probably the. And you just sort of start putting these together, and slowly stuff starts to sort of make sense, and then you're able to reference off of that. Also, the arrangement of letters. T and H show up next to each other a lot. So if you have, laughing and crying emoji showing up to each other a lot, maybe they're T and H. Throw that in and see what it turns out. Any ideas of how to defend against this basic type of frequency analysis if you're writing the code?
add diffusion, so you spread out the plain text.
Just asking Julie about the words related to cryptography, and she just got back to me because I forgot a bunch of those.
Yeah.
I just took my exam over this.
Yeah.
What diffusion and confusion?
I haven't gotten it back yet.
Just took it.
Yeah. Anyway, so the fancy word is diffusion, which is basically trying to flatten that line. As I mentioned before, the Visionaire cipher, which I've already erased in my infinite wisdom, because each every mod 3, so like 0, 3, 6, etc., if the key is 3 letters, will have a different frequency. Because it's if you have a 3-letter key, it's basically 3 different shift ciphers. Am I losing people? No. Okay. And so then that will slowly start to level that out if you have a longer key. Because the chance of the E's will be in different places for a bunch of them. I think people are kind of getting that from what I'm trying to say. So then a brief thing on breaking a Visionaire cipher, which I'm assuming you've done or about to do.
Yeah, we did that.
Yeah, you have to.
Yeah, we did that in one of our first labs.
Don't try to do this by hand.
It's just as much work in Python, but then you can do it infinitely.
Yeah, I don't think it's just as much work.
But
Anyway, so breaking a Visionaire cipher, as we mentioned before, you're diffusing it across. So you have to do like a multiple steps. You have to find, the best way is to find repetitions in your ciphertext. So if you have Q, I don't know, X, Y, and that shows up a couple times in your large enough ciphertext, well, you can go, well, the key is probably 3. Or if you see something that's a 3 show up and a 6 show up, and so like a bunch, like you try to figure out like with which like multiples of each other to try to guess the length of the key. And then once you guess the length of the key, you solve each letter of the key on its own. And a lot of this is sort of guess and check. Once you get a couple letters right, it starts going faster because you got a 3-letter word with T blank E, probably an H for that one, and then that H will solve something else. Yeah. And then we've kind of mentioned this throughout about what makes a good code. There's the keywords of confusion and diffusion. Confusion is the changing like the plain text into ciphertext, like you don't know what an A means in the ciphertext. And the diffusion is trying to flatten that out. You don't want to have a common distribution. And then modern codes are a lot more complicated with this because they have computers. Normally they're iterative. So you'll take the key, you'll expand it out, and then you'll use subsets of that key to like continually encrypt and mix stuff all around, which makes it a lot more difficult. There was the grad class here that teaches that really well if you want to struggle through all of that math. That is all I had, and it's horrifically short. So, does anyone have questions? No questions?
What is the best encryption method currently available?
Yes.
Depends on what you want
Symmetrical or asymmetrical?
Yeah,
One-time pad.
Yeah, one-time pad, right.
Yeah.
So if you're familiar with that, is you have to have a key that's the same length of your message. And is everyone familiar with the XOR operation? So it's,
An exclusive or.
an exclusive
Draw the truth
or.
table.
So like the good old truth table, if you've taken, what is that, 281?
Yep.
That's the XOR gate. And it's fun because you can XOR it with itself. But the thing is you can't tell. It can be anything based on the key. So you can't tell whether that bit is a 1 or a 0 because it directly references to a single bit of the key. And if you change the key at all, you can make any message.
But if your one-time pad gets leaked,
Yeah, but if your one-time pad gets leaked, or if you use it more than once,
why I
then you have a
see-
lot of problems with that.
that's why I said symmetrical or asymmetrical, because in this symmetrical case, you have to somehow get the pad to the other person.
Which is the problem.
Which is
If I'm
why
going to
we
be able
have
to send you,
asymmetrical.
a 10 megabyte, if I need to send you a 10 megabyte file encrypted, and I have to send you a 10 megabyte key to use that safely, then why don't I just send the 10 megabyte file that way? Is kind of that thought process. There's asymmetric encryption, which is based on public and private keys and stuff like that, which is the idea is one key can lock it, the other one can open it, but like the public key can't open it and stuff like that.
So the recipient sends an open box, and then you lock it with your private key, and they can only open it with. Does that make sense? You can look at the diagram.
Okay.
Big enough?
Oh yeah, I'll turn it over to you, and you can do that.
I'm just gonna shill for a minute here.
Just need to plug this in for a minute. So there's not a whole lot of people here today, unfortunately. So you're gonna have to share this with your friends. And I don't have dates on this, but congratulations, you're all invited to Spooky CTF. It's gonna be held by ISAG on the 29th of October, so Friday of Halloween weekend, from 3 to 8.